Bismillahirrahmanirrahim. Hello friends, peace and blessings. In this video, we will discuss Ohm's law. I hope that this video will help you understand Ohm's law in an easy way because this is a demonstration based video which makes it interesting and easy to understand Ohm's law. And credit goes to the Phet website as well. Phet is the collection of free interactive maths and science simulations for teaching and learning. The best thing about these simulations is that it can be downloaded and used even offline. I highly recommend you to visit Phet for fun simulations. I will leave the link in the description. A German physicist and mathematician, Georg Simon Ohm, after conducting several experiments, found that the potential difference across the ends of a conductor is directly proportional to the current flowing through the conductor, provided that the resistance and physical state of the conductor is unchanged. That is, potential difference is directly proportional to the current. By removing the sign of proportionality, we get V equals current times resistance, where resistance is the constant of proportionality and resistance is the opposition to the flow of the current. Unit of the resistance is ohm, and the above equation can be written as resistance equal to the potential difference V divided by the current I. Now let us define 1 ohm resistance. The resistance of a conductor will be 1 ohm if the potential difference applied across the two ends of the conductor causes the flow of 1 ampere current through the conductor. Hence, 1 ohm equals 1 volt divided by 1 ampere. The above relation, that is, the potential difference divided by current, shows that the ratio of the potential difference to the current will always give us a constant value. And this relation also tells us that the current I is inversely proportional to the resistance R, which will be demonstrated later. But before getting into the deep, let us discuss voltage and current briefly. Voltage or potential difference. Generally speaking, voltage is a pressure that causes electric current to pass through a conductor. In other words, the potential difference or voltage is the difference of electric potentials across the ends of a conductor. Mathematically, potential difference equals current multiplied by resistance. The unit of the potential difference is volt. Now let us define 1 volt potential difference. The amount of the voltage will be 1 volt if it causes the flow of 1 ampere current through the conductor having the resistance of 1 ohm. Now let us define current. Current is defined as the flow of electric charges, that is, electrons or ions, through a conductor. Mathematically, current I equals potential difference V divided by resistance R. The unit of the current is ampere, denoted by the capital letter A. Now let us define 1 ampere current. The amount of the current flowing through a conductor of 1 ohm resistance will be 1 ampere if the voltage applied across the ends of the conductor is 1 volt. Now, let us demonstrate Ohm's law using Phet simulation. The components that we need are bulb, a battery, an on-off switch, connecting wire, a voltmeter, which is a device to measure the voltage, and an ammeter, which is a device to measure the current. The arrangement of the circuit is given as follows. Before getting started, if you like this video, I request you please like and share this video, and don't forget to subscribe to my YouTube channel because it will definitely raise my courage and will motivate me to upload even more better content. Now, let us demonstrate Ohm's law. As soon as the switch is turned on, you can see that current starts flowing, which is indicated by the movement of the arrows. Here you can see that the potential difference or voltage is 9 volt and the value of the current is 0.90 ampere. Now Let us double the value of the voltage. That is, increase the voltage up to 18 volts. Now, observe the value of the current in the ammeter, which is 1.80 ampere. It clearly shows that increasing the voltage by 2 times will also increase the current by 2 times, which means that the potential difference V is directly proportional to the current. According to the Ohm's law, we can prove that the ratio of potential difference V to the current I is always a constant value. Now let us verify this statement with the help of Phet simulation. For this purpose, let us change the voltage to 50 volts. Now you can see that the current flowing through the bulb is 5 amperes. If we divide the potential difference by the amount of the current, that is 50 divided by 5, we get a resistance of the bulb which is 10 ohms. Now let us check the resistance of the bulb by clicking on it. Here you can see that the resistance of the bulb is 10 ohm. Now let us change the values. That is, if we increase the voltage up to 120 volts. Now observe the value of the ammeter, which shows that the current flowing through the bulb is 12 amperes. Now if we divide the potential difference by the current, that is 120 volt divided by 12 ampere, the resistance of the bulb is again 10 ohm. Now let us check our answer by clicking on the bulb. Here you can clearly see that the resistance of the bulb is again 10 ohm, which satisfies the condition, that is, the ratio of the potential difference to the amount of the current is always constant. Now we can prove that the current and resistance are inversely proportional to each other. Let us suppose that the resistance of the bulb is 10 ohm, and if you look at the ammeter, the amount of the current is 12 ampere. Now let us see what happens if the resistance of the bulb is increased up to 20 ohm. As soon as the resistance of the bulb is increased up to 20 ohm, the current becomes 6 ampere. It means if we double the value of the resistance, the current becomes half of its initial value. It proves that the resistance and current are inversely proportional to each other. Let us use Ohm's law to calculate the unknown values of the voltage, current, and resistance. Problem number 1. Suppose that potential difference is 10 volt, the amount of the current is 2 ampere, then what will be the value of resistance? Well, by using the relation, that is, the resistance is equal to the voltage divided by current. Putting values in above equation, R equals 10 divided by 2, which gives us 5 ohm. Let's take another example. Here, the amount of the current is equal to 1.2 ampere. The resistance of the bulb is 5 ohm. What will be the potential difference? We will use the relation, that is, the potential difference equals the current multiplied by the resistance. Putting the values, we get 1.2 ampere multiplied by 5 ohm. So the final value of the potential difference is equal to 6 volt. Now let us proceed towards the Next problem. In this problem, the potential difference is equal to 120 volt. The resistance of the bulb is 75 ohm. Then, what will be the value of the current flowing through the bulb? We know that the current is equal to the potential difference divided by resistance. By putting the values in above equation, we get 120 volt divided by 75 ohm, which is equal to 1.6 ampere. If you feel it difficult to memorize the different formulae of Ohm's law, don't worry. Remember the Ohm triangle. For example, if you want to calculate the value of potential difference V, then V equals the current multiplied by the resistance. And if you want to calculate the value of the current using Ohm's triangle, we can see that the amount of the current will be equal to potential difference divided by resistance. Similarly, the resistance will be equal to the potential difference divided by current. Today's topic ends here. See you soon in next video. Take care and stay blessed.